Continuing on in section 9.5 here, we're going to find the vertex of each parabola using the method of completing the square. So here, to complete the square, we're going to move the 10 to the other side. And again, if you want to put the 0 here first, you can. We need to move the 10 to the other side because the only things we want on the side of our equals that we're working with are our x squared and our bx term. So we move the 10 to the other side by subtracting it. Now, I'm going to take my b value, half it, and square it. 4 divided by 2 is 2, and when I square that, I get 4. And I have to add that to both sides, because whatever we do to one side, we've got to do to both. What that gives me then on the right side is a perfect square trinomial. So I can rewrite this as x plus 2 squared. Okay, it's just like when we factored last chapter, x squared plus 4x plus 4. Okay, we factored that into x plus 2 squared. On the left side, plus 4 minus 10 gives me negative 6. Now, instead of solving this completely, guys, we're just putting it in vertex form. So I'm going to move my 6 to the other side. And change my 0 back into a y. So now I have y equals x plus 2 squared plus 6. Vertex form, standard form. My vertex, remember, is x minus h squared plus k in my vertex form. So we take the opposite of our middle, the opposite of what's inside with our x, so negative 2. And then my k is 6, or my y value there. Okay, and I remember that because the h is inside with my x, and the k is on the outside, like my y. So that's how I remember the order there. So negative 2, 6 is our vertex there. Same idea here for b. First thing I'm going to do, and if you want to keep the y, you can, or you can put the 0 in, either way. Sometimes it's easier to look at if we don't have that y there as well. First thing I'm going to do then is get my equation set up so that I have a squared plus bx on one side and everything else on the other. So I moved that 34 to the other side. Now I can complete my square. I can rewrite this equation so that I have a perfect square trinomial. And I do that by taking my b value, the number in front of my x, halving it, and squaring it. 12 divided by 2 is 6, and when I square that, I get 36. And I add that to both sides. Okay, 36 minus 34 is 2. And my x squared plus 12x plus 36, I can rewrite as x plus 6 squared. And again, if you're not real confident with those factors, remember that we can take our value over here and just add our x in there. And since it's a positive 6, it's a plus. Now, again, we're not solving, we're trying to get it in vertex form. So I move my 2 back to the other side so that everything's back on one side. Okay, everything's on one side of the equals. Now I can put my y back. And I have y equals everything else, just like how we started. Here's my vertex form. Here is standard form. Now, we don't want just vertex form, we want our vertex itself, which is y equals x minus h squared plus k. So again, we take the opposite of our number inside with our x. So right now I have plus 6, we take the opposite, negative 6. And our k gets everything afterwards. So here we want plus k, which is like plus a negative 2. So the negative goes with our number. Sign goes with our number afterwards. We want exactly what's there, but inside we want the opposite, guys. Minus or a negative is just like saying the opposite. So here it's negative 6, negative 2. In example 4, we're completing the square. You are planting a flower garden consisting of 3 square plots surrounded by a 1-foot border, as shown on page 578. So here I have a kind of rough drawing of it. The total area of the garden and the border is 100 square feet. What is the side length x of each square plot? So we know area equals length times width. We need to figure out what our length is. Here I have 1 plus x plus an x plus an x plus 1. So I have 3x plus 2. That's my length. My width is 1 plus x plus 1. So x plus 2. And this is going to equal 100. Okay, it says the total area, so that goes in for A. Now, we did problems like these before. We have to FOIL out before we can move everything to one side. Again, when we have quadratics, we have to get it set equal to 0 to start with. Here I'm just foiling. First, outsides, insides, lasts. We can combine our like terms. 6 plus 2 is 8, and I keep my variable as an x. Now, I can subtract the 100 to get it set equal to 0. You can try and factor here using the swing method, but we're not going to get factors that work out. So, using our factors and our zero product property, not an option. So instead what we're going to do here is we're going to complete the square. Before we can do that though, we have to get it so it's just x squared plus bx equals some number. Okay, so in order to do that, I'm going to add the 96 back to the other side. So here we could have just subtracted 4, and that would have worked as well. But I wanted to show you guys that there we could have tried to factor like we did in sections prior. I also, guys, need just a 1 in front of my x squared. So I need to divide everything by 3. I'm going to get 32 equals x squared plus 8 over 3x. Now, complete the square. We take our b term, half it, and square it. When we divide with fractions, guys, we multiply by the reciprocal. This is 2 over 1, so we multiply by 1/2. Multiply straight across, 8 over 6, which reduces. I can take a 2 out of each of them to be 4/3. So here I get 4/3 when I half it. And now I square it. 4 squared, 16. 3 squared, 9. So 16 over 9 is going to be what I add to both sides. Okay. Now, I'm going to rewrite this in factored form as a binomial squared. And I can do that from after I half my b term, I can put x plus in there. If I already have a negative there, like if this would have been a negative 8 over 3, then I would just put x minus 4/3. But here it's a plus because it was positive. Our sign in our parentheses always matches our middle. And again, if it's the fraction part that's throwing you guys for a loop, try it and then check it with your calculators if you need to. Here, common denominator is going to be 9, so I need to multiply by 9. 32 times 9 is 288 over 9. Now I can go ahead and add there. I'm going to get 304 over 9. And that's because once I have a common denominator, I can add my numerators, keep my denominator. Again, this is just fraction stuff. Okay, nothing new there. Now, we are going to solve. To get rid of the square, we are going to take the square root of both sides. And when I do that, it's plus or minus the square root. Square root of 304. 304 is not a perfect square, so we leave that. But we know that the square root of 9 is just 3. So I can take that out of my radical as a 3. Square root of 9 is 3, so we write just 3. Here, I have x plus 4 over 3. Because I took the square root and that got rid of my squared. We're going to subtract 4/3. So I'm going to have x equals negative 4/3 plus or minus the square root of 304 over 3. Because I have a common denominator, I can keep that denominator and write it all over 1. So x equals negative 4 plus or minus the square root of 304 over 3. Not super helpful there. Doesn't give us that x value. If I walk in somewhere and I say, I need the perimeter on this square to be negative 4 plus or minus the square root of 304 divided by 3. If I walk into like Menards or Riverside, they're going to look at me like I'm crazy. So here we're going to find some decimal approximations. I'm going to take negative 4 plus the square root of 304 and then divide it by 3. Remember, you either need to press enter or put your numerator in parentheses. I'm going to get approximately 4.48 here, and this is in feet. If I do negative 4 minus the square root of 304 and then divide by 3, I'm going to get x to be approximately negative 7.15. Keep in mind, we're talking feet here. Can we have negative 7 feet? No. So the only answer we're going to go with here is that it's going to be about 4.48 feet. Okay, so each side of our plots are going to be 4.48 feet. Now, we're looking at the same kind of picture as we were before. Keep in mind, guys, that this is not perfect by any stretch, but the area here is still going to be length times width. Our total area is 150. Our length, 1, plus x, plus x, plus x, plus 1. That didn't change. 3x plus 2. Width, 1, x, and 1. X plus 2. So again, that didn't change. So our first step still is going to be to simplify each side before we can combine them. We're going to FOIL here. 3x squared plus 6x plus 2x plus 4. And then combine our like terms. Now, we're going to get this into a form that we can complete the square. So I'm going to move everything that isn't my x squared or my x term to the other side. And I have to get my leading coefficient to be 1, which means I can't have a number in front of my x squared, so I have to divide everything by 3 there. That doesn't simplify, so I'm going to leave it as 146 over 3. Again, now we're going to complete the square. I take 8/3, half it, and square it. We said that was 4/3 squared, which gave me 16 over 9 that I add to both sides. And I can write that as x plus 4/3 squared. Again, we put our x in there with a plus. Here, common denominator is 9, so I got to multiply by 3, which gives me 438 over 9 plus 16 over 9, which, since I have a common denominator, I can add my numerators and get 454. And again, you can do all the fraction work on your calculator if you're not confident. To get rid of the square, we're going to take the square root. And again, the square root of 454 is not a perfect square, but the square root of 9 is. It's 3. And remember, we have to do the plus or minus there. And here we just have x plus 4/3. To get rid of addition, I subtract. And I get x equals negative 4/3 plus or minus the square root of 454 over 3, which, since I have the same denominators, I can take negative 4 plus or minus the square root of 454 all over 3. To find our decimal approximations here, when I do plus, I get 5.77 feet. When I do minus, I get negative 8.44 feet. And we can't have negative 8 feet, so here, each side is going to be approximately 5.77 feet. Quick recap here. Any quadratic equation can be solved by first writing it in the form m² = n. And that's all I have for section 9.5.